Today we will discuss about the hand. The hand has two surfaces. One is anterior surface or palmar surface, and another one is a posterior surface or dorsal surface. So today we will discuss about the palmar surface of the hand, or you can say the front of the hand. Now let's see what is the hand. The hand is the distal part of the upper limb, and it performs some complex fine motor tasks such as grip, handling, writing, painting. So the muscles of the hand, it helps us in any complex movement. So what are the structures in the hand? We can divide the structures in the hand into from above downwards: skin, superficial fascia, deep fascia, and the contents. Within the contents of the hand are muscles, vessels, and nerves. So at first we will go into the skin of the palm. Okay, the outermost covering of the hand is the skin, but the skin of the palm has special characteristics. So what are they? It is thick. The skin of the palm is thick. Number two, it is devoid of hair and sebaceous gland. The skin of the hand, it doesn't contain any hair or sebaceous gland, but it is supplied by numerous sweat glands. Number three, the skin is immobile. That means it is not movable because it is firmly attached to the underlying palmar aponeurosis. This palmar aponeurosis is deep fascia of the hand. So the reason behind the immobility of the hand is the firmly attachment of the skin with the deep fascia or palmar aponeurosis of the hand. And the skin of the hand also possesses some skin creases, some longitudinal and some transverse skin creases. So these are some special characteristics of the skin of the hand. Okay, so these are some creases, some horizontal creases and some longitudinal creases. Now let's see a clinical condition that is called Down syndrome. You will find this kind of patient in the pediatrics ward or when you go into the medicine ward. The Down syndrome patient can be identified in childhood by seeing the palmar creases. The person who have a single or only one transverse palmar creases, this is called simian creases, and if this present in one patient, this patient is definitely has Down syndrome. That means the patient of Down syndrome has a single transverse palmar creases on the hand. That is called simian creases. So what does it look like? Suppose this is the hand of a Down syndrome. So look at that. There will be a single transverse creases. There will be no other creases. Only one single transverse palmar creases. It indicates the Down syndrome. Okay. But in a normal people, look at it. There are multiple palmar creases, transverse, two, one longitudinal and another longitudinal. Okay. So there will be numerous palmar creases, but in case of Down syndrome, there will be one single transverse palmar creases. By seeing this single transverse palmar creases, we can identify the patient of Down syndrome. Now our second structure is the superficial fascia of the palm. It is a dense fibrous band which anchors the skin with the deep fascia, and it presents two important structures. This is the one subcutaneous muscle, that is the palmaris brevis, and one ligament, that is the superficial metacarpal ligament. specialized to form three structures. Deep fascia of the palm, they form three important structures. These are the flexor retinaculum, palmar aponeurosis, and fibrous flexor sheaths of the digits. So at first, go to the flexor retinaculum or transverse carpal ligament. It is a strong fibrous band which bridges the anterior concavity of the carpus bone, that means carpal bone, and convert it into the osteofibrous tunnel, that is called carpal tunnel, for the passage of flexor tendon of the digits. It is rectangular in shape and is formed due to thickening of the deep fascia in front of the carpal bones. So let's see which one is the flexor retinaculum. So this is flexor retinaculum. What is it? It is a strong fibrous sheath. It is a strong fibrous sheath in the wrist, okay, and it makes the anterior concavity of the carpal bone into a fibro-osseous tunnel, that is called carpal tunnel. So this is the carpal tunnel. So how it is formed, or what is the boundary? Medially, it is formed by the two bone. One is pisiform bone and another one is hamate bone. So these are the two pictures of the flexor retinaculum. One is showing the proximal row of the carpal bone, and another is showing the distal row of the carpal bone. So medially, flexor retinaculum, it is attached with the pisiform bone and hamate bone, and laterally it is attached with the tubercle of the scaphoid bone and crest of the trapezium bone. Okay, and this greenish structure is the actually flexor retinaculum. So the flexor retinaculum, it converts. The flexor retinaculum converts this concavity of the carpal bone into a tunnel. So this is the carpal tunnel, and this greenish structure is the flexor retinaculum. Now we should know what are the important structures that passes through the carpal tunnel, or we can say just below the flexor retinaculum, and what are the important structures that passes above the flexor retinaculum or superficial to the flexor retinaculum. Now let's know what are the structures that passes superficial to the flexor retinaculum. The structures are from medial to lateral: ulnar nerve, ulnar artery, palmar cutaneous branch of the ulnar nerve, tendon of the palmaris longus muscle, palmar cutaneous branch of the median nerve, and radial artery. Okay, so these are the structures that passes above the flexor retinaculum or superficial to the flexor retinaculum. Now let's know what are the structures that passes through the carpal tunnel or just below the flexor retinaculum. So these are the flexor tendon of the flexors of the muscles of the forearm. So what are they? Number one is the flexor digitorum superficialis, tendon of the flexor digitorum superficialis, tendon of the flexor digitorum profundus, tendon of the flexor pollicis longus, and one important structure, that is the median nerve. Okay, so the tendon of flexor digitorum superficialis, tendon of flexor digitorum profundus, tendon of the flexor pollicis longus, and one important nerve, that is the median nerve. We have to know one clinical condition, that is called carpal tunnel syndrome. Okay, one clinical condition that is called carpal tunnel syndrome is a clinical condition where the median nerve is compressed in the carpal tunnel and produces some signs symptoms. So we already know within the carpal tunnel the median nerve passes. So if any condition that compresses the carpal tunnel or the space is narrowed due to any reason, then this median nerve will be compressed. So the muscles or the area of the skin that is supplied by the median nerve will be hampered, and that clinical condition is called carpal tunnel syndrome. So in the latter part we will know about detail about this. Our next modification of the deep fascia is the palmar aponeurosis. The palmar aponeurosis is nothing but one kind of deep fascia of the palm, and it is thin over the thenar and hypothenar eminence, and it is thick over the central part of the palm, where it forms the palmar aponeurosis proper. Okay, so let's see. This is the palmar aponeurosis. Okay, this is the palmar aponeurosis. Look at that. It is thinner over the thenar eminence and hypothenar eminence, but it is much thicker over the central part or medial part, and it has some parts. Look at that. This is the apex. This part is the apex. This part is called base. This is the lateral end, and this is the medial end. So this is palmar aponeurosis. It covers the long tendon of the flexors muscles and as well as the superficial palmar arch, which is the arterial arcade. So we have seen that the apex is directed towards the wrist and the base is directed towards the root of the 4 digits. Now the apex, it is blended with the flexor retinaculum, and the base is attached to the proximal to the head of the metacarpal, and at the base it divides into 4 longitudinal slips, each of the medial 4 fingers, and each slip further divides into 2 slips which blend with the fibrous flexor sheaths of the corresponding digits. That means, look at that, at the base they form 4 slips. Okay, and before insertion they further divided into 2 slips, and ultimately they inserted into the fibrous flexor sheath of the each corresponding digits. Okay, and the medial border, it is continuous with the deep fascia of the hypothenar muscles, and the lateral border, it is continuous with the deep fascia of the thenar muscles. Now, what is the function of this palmar aponeurosis? The palmar aponeurosis helps us in the gripping movement of the hand, and it also protects the underlying tendons, nerves, and vessels. Okay, so it protects the underlying tendon of the flexors muscles, underlying vessels such as palmar arches, and the underlying important nerves such as median nerve and ulnar nerve. Okay, so it helps in the gripping function of the hand, and it protects the underlying tendons, nerves, and vessels. Now, one important clinical condition we should know about the Dupuytren's contracture. What is it? It is a progressive fibrosis and thickening of the medial part of the palmar aponeurosis. That means on the ulnar side of the hand, the palmar aponeurosis is fibrosed and thickened, and its consequences are there will be permanent contracture of that part and causing flexion deformity of the little and ring finger. This condition is called Dupuytren's contracture. So let's see. Look at that. It is a clinical condition where there is progressive fibrosis and thickening of the palmar aponeurosis at the medial side. So these palmar aponeurosis will be thickened and fibrosed. So there will be permanent contracture of the fingers, these 2 fingers. There will be flexion deformity. That means ring finger and the little finger, they will be flexed due to contracture of the palmar aponeurosis. So this condition is called Dupuytren's contracture. Okay. Of the fingers. So what is it? It is another kind of deep fascia of the palm on the anterior surface of the each digit. So this is the fibrous flexor sheath of the hand, and it is present on the each digit. Means covering the tendons or some muscles, there are some layer of synovial sheaths, and they contain synovial fluid, and this layer of fluid that prevents the friction of the tendons during movement. So let's see what is it. The synovial sheaths around the long flexor tendons serve as a lubricating device to prevent their friction while they move in the osteofibrous tunnel or carpal tunnel. Okay. So what is this synovial sheath? It remains around the tendon. The synovial sheath, it remains around the tendon, and it is a double layer consisting of an outer layer and inner layer, and within these two layers there is containing a fluid that is called synovial fluid. So the synovial fluid are located within the synovial sheath, and this synovial sheath covers the tendon of the flexor muscles, and the synovial fluid acts as a lubricating layer and prevents the friction of the muscle during movement within the osteofibrous tunnel, that is the carpal tunnel. Now look at that, the long flexor tendons of the fingers, that means 4 of the flexor digitorum superficialis tendon and 4 of the flexor digitorum profundus tendon. These tendons, while passing through the carpal tunnel, they are enclosed in a common synovial sheath, is called ulnar bursa. That means flexor digitorum superficialis and flexor digitorum profundus, there are 8 tendons. These 8 tendons are enclosed by a common synovial sheath, and the name is the ulnar bursa. That means they are covered by ulnar bursa. So look at that. This is the ulnar bursa. Okay. So there remains the tendons of the flexor digitorum superficialis and flexor digitorum profundus. Okay. Now the distal medial end of the ulnar bursa is continuous with the distal synovial sheath of the little finger. In our last picture we have seen, look at that, the distal medial end of the ulnar bursa, it is continuous with the distal synovial sheath of the ring finger. Okay, so ulnar bursa medially it is continuous with the distal synovial sheath of the little finger. So we can say any infection in the little finger that spreads into the synovial sheath of the little finger, it will definitely communicate with the ulnar bursa, and the infection may spread onto the ulnar bursa and may extend up to the forearm. So it is very dangerous. Now let's see about the radial bursa. Which one is the radial bursa? The tendon of the flexor pollicis longus, while passing through the carpal tunnel, it is enclosed with a synovial sheath known as the radial bursa. That means flexor pollicis longus tendon, it is enclosed by a synovial sheath that is called radial bursa. And what are the distal synovial sheaths? Distal, that means it will supply the digits, middle 3 digits. The flexor tendons of the digits, while passing through the fibrous flexor sheaths, are enclosed in the synovial sheath. The distal synovial sheath extends from the head of the metacarpals to the distal phalanges of the digit. That means these synovial sheaths that present on the digits, that presents from the head of the metacarpal up to the distal phalanx of the digits. So let's see. So this is the radial bursa. Okay, the tendon of the flexor pollicis longus is covered by the radial bursa. Okay, and which is the distal synovial sheaths. These distal synovial sheaths present in the medial 3 fingers, and they are extending from the distal phalanges of the each digit up to the base of the metacarpal bones. Now, what will be the importance? So why should know that these radial bursa and ulnar bursa, the synovial sheaths of the digits? Because the function of the ulnar and radial bursa and digital synovial sheaths is to allow the long tendon of digits to move freely or smoothly with the minimum friction between the flexor retinoculum and fibrous flexor sinus. That means this bursa or bursal sheath, they allows the freely movement and prevents the friction. Now we should know what is the clinical importance of it. While we prick a finger, tip of a finger, for collecting any blood sample for blood grouping or something else, we should collect the blood or prick the finger from the medial 3 fingers, because accidentally, if any infection occurs in these 3 fingers during pricking of the skin, so the infection will limit it up to this synovial sheath, that means up to the base of the metacarpal bone. It will not extend into the further area. But look at that, if we prick blood, so if we prick a finger or take blood from the little finger or the thumb, so then the infection will spread into the from little finger to the ulnar bursa and from the thumb into the radial bursa, and they will move or traverse along the tendon of the flexor digitum superficialis and flexor digitum profundus, and here the flexor pollicis longus, and ultimately they will go into the forearm. So infection from the little finger or thumb may spread through the radial bursa and ulnar bursa into the forearm. So never try to prick blood or take blood for any examination from this 2 finger. So we will prick the finger, you will take the blood by pricking these 3 finger, index finger, middle finger and ring finger. So that's the clinical importance. Muscles. What are the muscles that present in the hand? Muscles of the hand are called, another name is intrinsic muscle of the hand. Why it is called intrinsic muscle? Because their origin and insertions are wholly located within the hand. Okay, their origin and insertion not outside the hand, it is wholly within the hand. So that is called intrinsic muscles of the hand. Okay, so how many intrinsic muscles in the hand? There are 20 intrinsic muscles we have. These are arranged in 5 groups. Okay, and each group contains 4 muscles. So what are the groups? Thenar groups, hypothenar, lumbricals and interosseous. And each group contains 4 muscles. So 5 group into 4 muscles on each, so there will be 20 muscles. So the groups are the thenar, hypothenar, lumbricals and interosseous. Now let's move to the thenar muscles. At first, see which are the thenar muscles and which are the hypothenar muscles. Just look at the picture. The muscles which are located under the base of the thumb, these are the called thenar group of muscle, and the muscle group which are located under the little finger, okay, these are the called hypothenar group. So this is thenar, this is hypothenar group of muscles, and there are some form like structures. These are called lumbricals muscles, and there are some interosseous muscle. There are the palmar interosseous and dorsal interosseous. The palmar interosseous, that means that is located in between bone structures. So the interosseous muscles are located between metacarpal bones. Okay, in the palmar aspect, their name is palmar interosseous, and in the dorsal aspect their name is dorsal interossei. Now let's move to the thinner muscles. The thinner muscles, there are 4 thinner muscles: abductor pollicis brevis, flexor pollicis brevis, opponens pollicis, and adductor pollicis. Okay, so adductor pollicis brevis, flexor pollicis brevis, opponens pollicis, and adductor pollicis. Look at that. We already told that thinner muscles are located under the base of the thumb, and we know that another name of thumb is pollicis. So each of the name is under with the pollicis, opponens pollicis, and abductor pollicis. So their origin and insertion are not so much important. We must remember the nerve supply and action of this muscle. What will be the nerve supply? All the thinner muscles are usually supplied by the median nerve. The exception is the adductor pollicis. Adductor pollicis. It is supplied by the ulnar nerve, and rest are supplied by the median nerve. And there is a special muscle, that is the abductor pollicis brevis. Abductor pollicis brevis, it has dual nerve supply. It is supplied by both median nerve and ulnar nerve. So what will be the action of these muscles? Look at that, the name says its action. The abductor pollicis brevis, that means it will help abduction of the thumb. Flexor pollicis brevis, it will cause flexion of the thumb. Opponens pollicis causes the opposition of the thumb, and adductor pollicis, it will cause the adduction of the thumb. Now come to the hypothenar muscles. So there are also 4 muscles in the hypothenar group. So they are abductor digiti minimi, flexor digiti minimi, opponens digiti minimi, and palmaris brevis. So why are they called digiti minimi? Because they are located under the base of the ring finger, and we know that another name of ring finger is digiti minimi. So that's why the digiti minimi suffix is added in each and every muscle. Now you should know the nerve supply of these hypothenar muscles. The nerve supply of the hypothenar muscles are supplied by ulnar nerve. So all these muscles will be supplied by the ulnar nerve. Okay. And another name of ulnar nerve is called musician nerve. Why it is called musician nerve? Because one thing I want to add that all the muscles of the front of the hand are supplied by the ulnar nerve, except the muscles are located in the thinner muscles. So except the muscles are the thinner group, that are located in the thinner group. So maximum muscles are supplied by the ulnar nerve, and you know the intrinsic muscles of our hand are involved in the complex movement, such as writing, then for any instrumental purposes, for any painting, drawing. So that's why the ulnar nerve is called musician nerve, because the ulnar nerve supplies the intrinsic muscles of the hand, and these intrinsic muscles of the hand are involved in precise movement like drawing, painting, and for any instrumental play. Okay, so the hypothenar muscles are supplied by the ulnar nerve. Now come to the action. The action is very easy. Abductor digiti minimi will cause abduction of the little finger. Flexor digiti minimi will cause flexion of the little finger. Opponens digiti minimi will call with the opposition movement of the digiti minimi or little finger. Okay, now come to the palmaris brevis. We have already studied this muscle, palmaris brevis, because it is located in the superficial fascia, and it is a very subcutaneous muscle. Okay. And what was the function of the palmaris brevis? We studied earlier. That is it helps in the grasping movement of the hand. Now come to our next muscle is the lumbricals muscle. Okay, the lumbricals muscles, there are four in numbers, and they are numbered first, second, third, and fourth from lateral to medial side. Okay, so from lateral to medial, they are numbered as first lumbrical, second lumbrical, third lumbrical, and fourth lumbrical muscles. Okay, and they look like worm-like shaped. Okay, lumbricals means worm-like, so they look like worm-like, so that is called, the name is lumbrical muscles. So this is the muscle. We should know the origin and insertion of this muscle. The lumbricals, they look like worm-like. We know the worm are not independent. They depend on the other structures to live. So as the worm, the lumbricals have the same characteristics. The lumbricals doesn't get origin from a bone, and it doesn't insert any bone. Look at that. It is originating from the flexor digitorum profundus, the tendon of the flexor digitorum profundus. From here it is originated, and it is inserted on the dorsal digital expansion on the dorsal aspect. So it is originating from the flexor digitorum profundus, and it is inserting in the dorsal digital expansion. Here is the table where you can see the actions of these thenar and hypothenar muscles. Now the lumbricals muscles, it is also supplied by the dual nerve. It is the first and second lumbricals are supplied by the median nerve, and third and fourth by the ulnar nerve. So first and second supplied by the median nerve, and third and fourth lumbricals is supplied by the ulnar nerve. Then the actions. What is the function of the lumbricals muscle? So look at that. This is the lumbricals muscle, first, second, third, and fourth. The functions of the lumbricals are they causes flexion of the metacarpophalangeal joint, and they causes extension of the interphalangeal joint. So these are the metacarpophalangeal joint. So they will go flexions of the metacarpophalangeal joint. The lumbricals causes flexions of the metacarpophalangeal joint and extension of the interphalangeal joint. And you can see the first and second lumbricals muscles, they are unipinnate muscles, but the third and fourth, they are bipinnate muscles. So you should remember this. Then interossei muscles. So there are 8 interossei muscles, 4 on the palmar aspect and 4 on the dorsal aspect. So the palmar aspect, there are 4 interossei muscles, and they are numbered as first, second, third, and fourth from the lateral to medial side. And it is same as the dorsal interossei. And the nerve supply, the palmar and dorsal interossei are supplied by the ulnar nerve. All the palmar and dorsal interossei will be supplied by the ulnar nerve. Okay, so what will be the functions of the palmar and dorsal interossei? Look at that. These are the palmar and dorsal interossei. These are the palmar interossei, and these are the dorsal interossei. Okay. So look at that. All are inserted on the base of the proximal phalanx. And they also inserted in the dorsal distal expansion. And we have already studied that the lumbricals muscles originate in the tendon of the flexor digitorum profundus muscle, and they are inserted in the dorsal distal expansion. And look at that. So the dorsal distal expansion, here there is insertion of the lumbricals muscle, insertion of the palmar interossei, and the insertion of the dorsal interossei muscle. So the function of these 3 muscles will be same. So what is the function of the palmar interossei and dorsal interossei? Both these muscle will causes so palmar interossei and dorsal interossei, along with the lumbricals muscle, they will cause the same function. So what will be the function? Flexions of the metacarpophalangeal joint and extension of the interphalangeal joint. Besides this, the palmar interossei causes adduction of the fingers. The dorsal interossei causes abduction abduction of the fingers. Okay, so how will you remember which one will causes adduction and which one will causes abduction? We know adduction means the movement towards the midline. Actually, the adduction and abduction occurs at the axis of the midpoint of the middle phalanx. Sorry, middle finger. Okay, so at the axis of the middle finger, it acts as an axis for the adduction and abduction. If the finger moves towards the midline, that means towards the middle finger, it will cause adduction, and if the fingers move away from it, it will cause abduction. Look at that, we know the muscle acts on the site of insertion. Look at that, the palmar interossi. The palmar interossi are located on the medial aspect of the proximal phalanx. Okay, medial aspect of the proximal phalanx. So definitely, when this muscle will contract, they will move towards the midline. Okay, so the palmar interossi will causes adduction of the fingers. And look at the dorsal interossi. These are the dorsal interossi. The muscles, they are inserted on the lateral aspect of the base of the proximal phalanx. Look at that, the dorsal interossi muscles, they are inserted on the lateral aspects of the base of the proximal phalanx. Look at that, lateral aspect of the base of the proximal phalanx. And in the middle finger, they are inserted on each side, on the medially and laterally. So the medial finger will be fixed. But as the first dorsal interossi and fourth dorsal interossi, they are inserted on the lateral aspect of the base of the proximal phalanx. So this muscle will turn the fingers away from the midline. So there will be abduction. Find some vessels in the hand. These are the superficial palmar arch and deep palmar arch. And these superficial and deep palmar arch, they coming from the terminal branch of the radial artery and ulnar artery. Okay, radial artery and ulnar artery terminal branches, they anastomosis and form the superficial palmar arch and deep palmar arch. So we will learn these blood vessel systems in the later item. So in the front of the hand, what are the muscles? There are 20 muscles arranged in 5 groups: thenar, hypothenor, lumbricals, palmar interossi, dorsal interossi. What is the nerve supply? All the muscles of the hand palm of the hand are supplied by the ulnar nerve, except the muscles that are located in the thenar group, and they are supplied by the medial nerve. Okay, and what is the vessels of blood supply? They are the superficial and deep palmar arch. Okay, superficial palmar arch and deep palmar arch. These two are coming from the terminal branches of the radial artery and ulnar artery. So this is all about the front of the hand or palm of the hand. Thank you very much.